Hello, and how's it going, dudes? Brad the Guitarologist here, and on the bench today we have a massive Mesa Boogie Bass 400. As the name implies, this is a bass amp. They came out with these, I believe, in 80s, mid to late 80s, and produced them, I think, on through the 90s. This one has several problems. It basically said that it, when you try to use the effects loop, if I'm not mistaken, or you try to use the effects blend, it changes the volume drastically in ways that it shouldn't be doing it. We've got a bunch of tubes in there. We've got 1, 2, 3, 4, 5, 6 power tubes, and those are 6L6GCs. We have preamp tubes up there in the front. So you can see here it does say 1982 Mesa Boogie, so I guess they came out with this particular model in 82. We have fan, high, low, or off, and here's our big fan over here on the side, and that would be necessary for cooling this thing, especially if you were on a hot summer day, especially if it's up inside of a rack and there's really not a lot of airflow. We have a ground filter also. We have an effects blend which will blend the return with the through signal. We have a slave output. We have two 8-ohm outputs there, and we have two 4-ohm outputs there. We also have an XLR balance connector there, and that'll be for direct out to a board. This should be a really killer and useful bass amp for both live applications and for recording. But right now, it's down for the count. It has a sickness, and we're going to find out what it is. So if that sounds like something you'd be interested in, stick around. Okay, here we are with the lid off of this beast, and right there we have a code 606, which is Schematic 522. So this is a 1985. Here's the board for the EQ. I don't anticipate anything being wrong with that. And this one has a 1982 date on it as well, this board. Looks like we do have all original components. These caps are probably original as well. This thing has optional feet that go on the bottom, and they're missing on this one. Alright, that's a lot of caps. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 220 microfarad capacitors. So, with the age of this thing, because all of these are dated 1985 as well. Actually, these are dated 1978, so these are even older than that. They probably sat on the shelf for a while. I would highly recommend to this customer that we do a complete overhaul on this. That's going to include all new capacitors. There's one right there that's burned on the side. You see that resistor right there? There's some solder or something on the side of it. And that's obviously, these are obviously some power resistors over here, because they're kind of large, and they're also high wattage. Got some other higher wattage resistors over here along another power rail, or another part of the power rail. Every single one of these capacitors needs to be changed in this thing. This is going to be a pretty pricey thing to do, but it's really a necessary thing to do. Recapping this thing is probably about 50% likely to fix whatever was wrong with it. Now, it may not fix what was wrong with it, and I'm kind of hoping it doesn't, because it'll be a little more of an interesting video if it doesn't. We'll get with the customer on this, let him know that if nothing else, it needs to be recapped. Okay, box came in today, and it is a big old bag of capacitors. So that means we can get back to work on this Mesa Boogie. Alright, so I got an empty memory card, a full bag of capacitors, and some cutters, and we're going to get to work on this thing. Okay, so that's all the large capacitors complete. Now, I know there's always someone who's going to object to the method that I used in putting these capacitors in, soldering them to the existing leads. There's a reason I do that. There's actually a couple different reasons. First of all, It prevents me from having to solder directly on the pad, which can wear out the pad over time. So actually this thing will get more changes overall out of these pads if I don't touch them with my soldering iron when changing these. So that's one reason. The second reason I do it is because it's faster and it's going to save time and money for the customer. The third reason is it's going to be easier to change these the next time they need to be changed. So that's going to save time and money once again the next time. The fourth reason is it's hard to see underneath this board. So if I were to poke all of these leads through the board, I don't necessarily know if I've dropped a solder blob down to the bottom of the board and I've shorted something. I don't necessarily know without looking under there whether I have pushed the lead too far down in there and shorted something. So it's really safer just to do this, to leave it as it was from the factory, these leads soldered, and just solder to those leads. I've never really heard a good reason besides cosmetics why you would not do it this way. So what we're going to do now is we're going to come in and do all of the smaller electrolytic. Okay, this one up here is the exception. I'm going to have to solder this one into the board because my new capacitor is bigger than the old one. I'm having to go with a slightly larger value, a slightly larger power handling, that is. Yeah, I'm going to have to do the same thing with these other small ones. Okay, so that looks like all of them on this board. Let's flip the amp over and do the other side. Okay, this is the EQ board, and although this is probably not going to be critical, we're going to go ahead and recap it anyway. We got a couple of 220s here. Got a little 20, what is that, a 22 microfarad we're going to replace with a 25. These are some kind of oddball voltage ratings. 63, 10 microfarad at 63 volts. I'm not sure if it even sees 63 volts here, but I'm going to replace it with a 160 volter. Because a couple of these are oversized, once again, I'm gonna have to do it the old-fashioned way, desoldering the pads. Okay, so that is all of the electrolytic capacitors in this amplifier replaced. Okay, the way these pots are in here, they're in here in such a way that you can't really clean them without taking the board completely out. And I'm not going to take the board out to clean the pots, but what I am going to do is I'm going to spray at the very top with enough force that hopefully some spray gets in there, and we'll just kind of work the pots back and forth. I'm going to go ahead and also clean the input jacks over here, and I'm going to clean all these jacks on the back of the unit. There are a couple of pots back here for the slave level control and effects blend. So I'll go ahead and spray those out. Those are at least accessible. I can also pull the tubes, all the tubes, and spray all of the sockets, so we can at least give it a good clean before we do anything else. So let's do that. Getting right on the seam right there, and just kind of hoping some of it gets in there, just enough to wipe them down a bit. Alright, so let's clean some sockets now. I love this style of chassis, man. It's look look, I can just flip this thing any direction. I don't have to worry about the tubes getting broken if I flip it this way. I don't have to worry about the knobs getting broken off if I flip it up this way, because I've got those handles on the front, and it's just, you know, it just makes everything a hell of a lot easier to deal with. Very cool. Alright, what I'm going to do here, the way I like to deal with power tubes when they're like this is just go ahead and spread out the jaws, these retainers, spread them on out. There's no sense in trying to fight with them. And when you're pulling power tubes, that's another good point. Pull at the base, don't pull by the glass. If you can, I mean, sometimes you can't reach the stuff, but whenever possible, pull at the base of the power tube, not the glass. It looks like we have had one replaced socket, perhaps. I also did notice that we had a couple of replaced resistors, look like power resistors or something in there, and one had exploded at some point, leaving some black marks. There was actually a little spider's egg in one of those sockets. Now the last thing we need to do is recompress these jaws on each one of these. Okay, all capacitors are replaced, everything is clean, and I'm ready to hook up a load to it and dial it up slowly on the Variac. One thing I noticed plugging this in was I was plugging in the 8 ohm jack, and the 8 ohm jack was very weak, so I pushed the positive terminal back into place, and also noticed that these input jacks are very weak. Let's see if we can do the same thing to those. I'll show you what to do. There is a little terminal that needs to be bent downward. And let's start dialing it up slowly. Okay, probably around 30 or 40 volts on the input at the moment. Fan should start going at some point, I would think. I just want to kind of let these caps all form because it's entirely new capacitors, and I just want to kind of give them a chance to form up without shocking them to life. 65 volts, 0.7 amps, 43 watts of power were drawn, so something's working. Fan is beginning to move over here. Alright, we're up to 75 volts. I've still got nothing on the output. Oh yeah, I do. Yeah, that could use a real clean, but the problem is, once again, you would have to take the entire board and everything out to even begin to clean these pots. So that seems to work all right. Yeah, those are working. Okay, that's the effects blend. When you turn the effects blend on this amplifier, that's going to blend in whatever is coming through the effects loop, and if there is nothing coming back into through the effects loop, then it's going to basically you're going to lower the overall volume. So that makes sense that would happen. You need to keep that on 0 if you don't have anything going through the effects loop. Let's go ahead and dial it on up. I want to be very careful I don't blow this speaker. So I'm going to keep it very low on the volume. Alright, there's 100 volts. I'm going to let it set at 100 volts for a second before I dial it the rest of the way up. Alright, let's turn the master down a bit, dial it all the way up. When I got to about 114 or 115 volts there, I did hear some rustling of leaves on the output. Sometimes that can be indicative of like a bad resistor somewhere. But that also could be one of these pots that I wasn't able to really get to clean. Probably that treble right there. That's exactly what it was. Okay, we're all the way up, 120 volts. Alright, let's try the second input. Well, this one doesn't seem to be working at all. Alright, well, we know we need to do something with channel 2. Let's look at the schematic. Alright, here's a schematic for this thing. It's in 2 pages. This is the main page, and then you have the power stuff over on a second page. Okay, this is effects send and return up here where I would expect to see the input. Maybe the input, yep, the inputs are over here on this side. Alright, since input 2 is the one that's not working, we'll look at that. Input 2 goes into a 0.047 capacitor into the first stage. Where is the pot? That's the 1 meg volume pot. So if it's not the pot that's causing the issue, then it could be this 0.047 capacitor here, or this 0.047 capacitor here. I suppose it could also be this 15, what is this, a 15 microfarad capacitor here, and then of course we have a bias resistor here, so I suppose that could have drifted and played havoc with the bias on this tube. But that's the only thing I could think of that, you know, might be making the volume pot kind of cut out in the middle of its range like that. So yeah, I'm really looking squarely at this 0.047 capacitor right here. And also, while I'm thinking about it, I'll explain to you why when you turn the blend pot for the effects loop, if you turn it all the way one way, it basically cuts out all of the volume. If you look here, this is the stage right before the effects loop. The signal is traveling from right to left in this schematic. So the signal comes in here to this one, and then it's a cathode follower on this stage, so the signal goes onto the cathode and then through this 0.1 capacitor to here. Here's the ground reference, so it goes on up. It can go through the send and then your effects stuff and then to the return and back down, or it can just go straight down. If you have this blend pot set to where it's basically blocking all the signal, then, you know, obviously nothing's getting through. You could take a jumper wire and you could jumper it just from here over to here, and then you would see probably no difference. But yeah, essentially that's why when you turn this up past 0, you're essentially you're starting to attenuate what gets through to the other side. Here you have the jumper switch where it can go through the graphic EQ, and then it goes to the master and then on out. Alright, so let's shut her down and we'll go ahead and look for those capacitors now. And I definitely want to make sure I drain these capacitors. I don't want to screw around with having all of those caps that I just put in there discharge into me. I'll see how much of voltage is left in the amp. Okay, let's just pick one of these guys. 200 volts still lingering right there. Look at that. Not much right there. 85 there. I bet there's a bunch down here. 169 still right there. Yep. It's coming down, but it's taking a minute. There would have been 200 volts on my hands if I'd just stuck them in there. I really don't ever go into the safety stuff because the minute I go into safety stuff, it kind of assumes that you're going to be in your amps doing this, and at that point, I'm kind of giving you instruction. I'm admitting that I'm instructing you in what to do. And if somebody electrocutes themselves while I'm instructing you, then obviously there could be liability issues there. But I'm going to show you what I do to discharge capacitors. It's not what you should do to discharge capacitors. It's what I do. I get a gator clip. I hook one end of it to a ground point. I hook the other end to a 100 ohm resistor. That's a pretty big value. This one's about a 10 watt. And then you can just basically touch it, and you see the voltage disappear basically there. It'll try to reappear, but you just touch it to it and leave it to it for a good 20-30 seconds, something like that, and all that voltage will drain off through the wire. Again, this is what I do. I'm not advising you on what you should do. So okay, what I want to do now is look for that 0.047 capacitor, actually 2.047 capacitors. So let's look at input number 2. We have a black wire and a red wire coming off of there. The black wire back here is ground. The red wire coming over here is going to the 0.047 right there. Goes through the 0.047 to this point. That should be the grid of the tube. Okay, then it'll come out of pin 6 here. This will be the plate resistor here, but there should be a capacitor also coming off of the plate. Where's that capacitor? Because I don't see it. Oh, there it is. There it is, right there. It's that one right there. Whoa. Okay. On the other side of that capacitor, I have the same resistance. I think that capacitor right there is dead shorted. It's funny because the capacitor, it looks perfect. It looks just as perfect as the one beside it, but it measures a dead short. Yeah, see, it looks physically, it looks fine. Yeah, see, dead short. It's a bad capacitor. So there's that new cap in. I'm gonna guess that'll solve that channel's problems. What do you say? But yeah, that will explain also why we were getting so much swoosh, 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 swoosh on some of these controls, because yeah, the bass and treble and all that stuff would have been would have had high voltage on it. So no wonder. So I don't think they even were dirty. It was just that there was voltage on there. Let's go into channel 2. Yep. Channel 2 is fixed. And our swish, swish, swish on our EQ is not nearly as bad. Still pretty bad on that treble. You know, it would be nice to be able to get in there and clean that. Interesting. So the EQ is not working now. Why is that? Does it work on channel 1? No, it does not. Why does it not? I'm thinking I must have inadvertently knocked a wire or something loose. I had to have. So yeah, something blew when I replaced that capacitor right there, and I have no idea what it could be. I suppose it could also be just something on that board finally gave up the ghost, because you know, I changed those capacitors, all the capacitors on that board, and maybe something else other than the capacitors I put in went dead. Alright, here's a schematic for the graphic EQ portion, and as you can see, it has 4 different transistors on that board, and it's quite possible that by replacing those capacitors, you know, I gave those transistors more voltage than they have probably seen in, you know, 15 or 20 years, and you know, just by doing that, it could have killed an already weak transistors. That's possible. I'm kind of going on that theory, but I could put my meter a couple of these places and see if I can find negative 32 volts or negative 53 volts. Should see negative 20 volts down here. Let's fire it back up and see if we can't find these voltages. Yeah, negative 72 volts. So why would I be getting 72 volts instead of negative 50, what did I say, 52? 53 volts? Well, I guess it's a good thing I overrated these capacitors then, because the 63 volt capacitors that were in there couldn't have handled 72 volts. I think what I need to do, this gray wire right here is what's bringing in the voltage, so I guess I need to trace this gray wire back and figure out where that voltage is coming from and why it is more than it needs to be. So yeah, I am guessing for sure because it's you know, it's way higher voltage than it needs to be. It probably took out. It might have even taken out all of those transistors. That resistor right there above the 220 microfarad capacitor, where I should see 53 volts on that side and 32 volts on this other side, doesn't give me a value for that resistor. I think I need to change that resistor and drop the voltage until it gets to negative 32 volts. Okay, high voltage supplies, here we go. A, B, and C. Where's it getting its voltage from? See, it doesn't list it to the EQ right here. Okay. Okay. Yeah, this is the biased voltage winding. We have a diode here. The diode is working. This 475 ohm resistor is probably shorted. The other thing is, I was thinking, is that if one or more of these transistors were shorted or blown or open or, you know, not working, basically not operating, they wouldn't be drawing this voltage down. So this voltage would be higher if one or more of these wasn't working. Alright, so here's the other side of the amplifier, and you can see that gray wire coming out up there up front. That wire is what is supplying the power to the EQ board. It comes out over here, and if you trace it, it traces out to that resistor right there, which is a 475, yellow, purple, green. Alright, so that is 475 ohms, so that is not the problem. Okay, here again is the EQ board. We have 1, 2, 3, 4 transistors, and what I'm going to do here is just pull these out one by one. I've already tested them with my Fluke, and they test okay. If you want to test transistors, you can test them by looking for diodes. And right here, we should be looking for about a half a volt or so on most transistors. And here we have 0.7 on this one, 0.7 on the other leg. And I'll just let you know that this, all of these test okay. Same thing here. That one looks like it may have been changed at some point. And actually, it, just judging by the soldering as well, it looks like a different transistor. But it tests okay. Pulling that transistor out of circuit is going to allow me to test it on my little meter, my little transistor tester meter. And testing it out of circuit should be a little more accurate. Okay, so here's this transistor, MPS A92A28. Okay, it tests good, tests as a PNP. Okay, I got that one back in, and the next one I've taken out, and this is an A70. Okay, this one also is reading a PNP. Okay, this next one over right here is an A70, and it's a Motorola also, like that last one. This one also is measuring as a PNP transistor. Alright, let's pull this last one out of here. And like I said, it should be an NPN. And it is a Motorola A20. And at this point, I don't anticipate this being bad. I think it must be something else. Yeah, it's an NPN. My theory is incorrect. It is not the transistors. So there are all of those soldered back into circuit. The only thing I know to do is fire it back up and try to do some measurements. I'll poke around in here a little bit more and see if we can't figure out maybe a place where there's supposed to be voltage and there isn't, or a place where there's not supposed to be voltage and there is, etc. So here is one thing that I did notice. The switch that is used actually switches both ends when it's engaged. Both of these ends switch down here, and when it's not engaged, it goes to bypass mode, which is up here in these positions. But both ends switch at the same time, and it could be that one of these ends is not switching, that only one is switching. So it could be that this one is maybe stuck on bypass, for instance. So when you switch the switch to the off position, it works in the off position, but then when you switch it here, you're getting nothing because it's going in here and has nowhere to go because this end is stuck in the on position. So it could be, very well could be, that switch right there. So yeah, the board's going to have to come out for me to remove the switch, but that's what I'm going to do here. I'm going to remove that switch and we'll see if it's that. I'll also check, just go ahead and check that that foot switch also, foot switch jack. Okay, to get this out of here you got to pull all of these off. Okay, there are 3 screws that hold this thing in. There's one down there. I guess you got to get your screwdriver down in between here There's another one here, and then there's another one over here. You got to get your screwdriver down in between these faders, I guess, to do that. But that's kind of a long way down there. I wonder if there's a nut for each of those on the other side of the chassis. Well, if there is, it would be under the board, so basically our only option. Gosh, I hope there aren't nuts under there. I got the probe on the collector for now, and I've got my voltage right here at this point. Where I do not have the voltage, I should see negative 21.5 volts is right here. I see no voltage right there at that point, so that tells me something is wrong. Either this 470K is bad, this 3300 is bad, or this brand new capacitor that I put in, this 10 microfarad, is shorted, is pulling this voltage all to ground. It could also be the transistor itself, I suppose. But here, I'll show you what I mean. See, I've got my 66 volts right there on the collector, so that's right there at that point. But when I move my probe to the base, I have 1.9 volts DC, and I should be seeing 21.5 volts according to this schematic. Let's just spot check some of my other transistors. Let's try the bases of some of those, like this one for instance. 6.8 volts right there is all I'm getting, and I'm supposed to see around 20 there also. I think all these should show around 20 volts. 2.7 there, so yeah, so there's something wrong with the supply. I think what I'm going to do is just start with these components over here. There's also a capacitor down here. There's 100, what is this? It's a 0.047 at 100 volt to ground. Alright, so here's that capacitor that I thought might be suspect, and it is measuring just fine. Alright, let's do this 3300. It should be a 3.3K. Yep, that's fine. And let's do this other one over here. 465K, so 470K. Well. Alright, so let's yank that sucker back out of there again. So let's do that same measurement again with the transistor out of circuit. So basically that's the same connection as the base. So let's go from 13.8K. Alright, yeah, so 13.9K, that's there's no other path to ground except through Q1, and Q1's removed, so this is not connected to this point any longer. So that eliminates that as a possibility. It also eliminates this as any kind of possibility. So through the 1 meg, which is a 470K in this particular example, which measures fine, it's actually 470K. It would be interesting, I guess, to remove that and see if the value changes, but how is it getting to ground? I mean, it could be getting through this, but this measured fine also. The only other way would be if there was an internal short in the switch. So if the switch was grounded in a certain position, then it could be getting to ground that way. You know, gunk in the switch, dirt, you know, could be any number of things, I suppose. I could spray the switch out. Let me see if I can spray the switch out. I'm going to undo this foot switch and drop it out the back and investigate that. Spread these contacts open. I'll spray these and Just make sure they're getting a good connection when it's not engaged. I mean, it's still a bit of a mystery why there would only be about, you know, 14K of resistance between this point and ground, which is this point, just on the other side of this 1 meg, or 470K. There's just, you know, with this component gone, how are we getting there if not through the switch? But the next thing I want to check on is this capacitor right here. That's a 0.047 at 100 volts right there, and that is preventing all this DC that's on the other side of it. And there should be about 20.7 volts on the other side of that capacitor. It's preventing that from getting to ground. So if that's become leaky, that could be a problem as well. So let's find that 0.047. I think it's probably that orange drop right there. I think it's probably that guy. Yep, at 100 volts. Yep, that's what it's supposed to be, so that's fine. Okay, I'm going to lift the leg on this capacitor right here again and see if that path to ground goes away. I just, you know, because if it's not that, it has to be the switch. It really does. Alright, so from there to ground, and nope, still 13.8K. So the only way to ground really through, from there is through the switch. So it's got to be the switch, which makes the most sense. Okay, well geez, I finally got this thing out, and I actually had to use a flathead screwdriver. The only other long one I had is a flathead that would fit into the heads on those screws, just barely. Okay, so I pulled the switch out and tested it, and it's fine. There's no shorts or anything like that. It all works. So that's the switch is not the issue. Also, I did go ahead and test this foot switch as well, and it is also not the issue. Kind of at a loss. There's nowhere else to go with it. If it wasn't the switch, I guess I could test it again and see if we're still getting 14K even without the switch. Might be a good idea. Let's see. Now without the switch, we're getting 220K. That's climbing as well. Not sure why it would be climbing unless we have perhaps an issue with that capacitor right there. I'll tell you what I'm going to do. I'm just going to replace this capacitor, replace this other orange capacitor right here, because those two are definitely critical. Alright, I'll just be curious to test that again. I doubt it's going to make a difference, but well, that started out at 2 megs and it's working its way down. So that's definitely a change. Okay. Well, that's looking promising so far. But you know what? That looks a hell of a lot better than it did, doesn't it? Okay, well, let's get the switch back in and go from there. Okay, so there's the switch soldered back in. I would be interested to go ahead and do that measurement again. Let's try it again. Okay, started out in the 300s and it's working its way up. So that's actually an improvement. So what made the improvement was replacing this bigger capacitor right here. I'm fairly certain. And again, I also changed this transistor as well to another PNP. So yeah, let's hook our power cables back up. That's this black and gray one. I'll have to remember which is which, so we'll get those hooked back up and try it again. Alright. There it is, it works. Fantastic. So that works. Let's try the second channel. Okie dokie, fantastic. So that concludes our rather long video, I'm sure, on this Mesa Boogie Bass 400 amplifier. Hope you guys have enjoyed this one as much as I have not. And I hope you'll hit the subscribe button down below and also hit the bell to receive all notifications. And for now, y'all take care.